You launch a new AI coding agent, expecting it to build a feature, but it starts blindly guessing your framework and breaking your routing, burning thousands of tokens before it even locates your source code. This happens because standard agents reset after every terminal session. Without a configuration, they begin with zero knowledge of your tech stack, your naming conventions, or the specific architectural patterns you've established over months of work. Every morning becomes a repetitive loop, where you have to re-explain the same basics, like which testing library you use or which API endpoints are protected, only for the agent to forget them the moment you close the terminal. It doesn't have to be this way. By establishing structural scaffolding through persistent memory, reusable skills, and secure protocols, you can transform that agent into a reliable teammate in under 5 minutes. To set this up, you only need a local project and an active CLI agent like Claude Code.
Relying on unconfigured models guarantees wasted time and budget. The only way to move from simple autocomplete to autonomous coding is to build a foundation that persists across every session. The first pillar of your architecture is a permanent baseline memory file sitting right at the root of your workspace. This file acts as a README for the AI. You fill it with 3 specific things: your core stack details, hard architecture rules, and your preferred testing conventions. Because of the way these agents are built, the system autonomously loads and reads this specific file at the beginning of every new session. It absorbs your standards before you ever send the first command. However, you must be precise. A 500-line document of non-essential details creates context bloat, leaving zero space for reasoning. This carries a financial penalty. The system must reread that massive document every time it speaks, burning your API credits on noise. By restricting your memory file to absolute core rules, you ensure the agent spends its entire context window on solving problems, rather than violating your strictly established project standards. Even with memory, typing out complex instructions for recurring tasks like code reviews or API scaffolding remains a significant bottleneck. To solve this, you create a dedicated skills directory. This houses markdown files that store reusable instructions for specific, high-frequency workflows. These files are mapped to / commands. Instead of explaining how to perform a security review every time, you just type the command and the agent activates the associated file. The agent then executes the workflow autonomously, reading your Git diffs, checking against the skills rules, and producing the required output. This shifts your role as a developer. You stop managing individual prompts and instead start triggering pre-packaged workflows that can handle entire segments of your development cycle. As you grant the agent more autonomy, security becomes the priority. A dangerous but common habit is leaving raw API keys in configuration files so the model can access external data. If raw credentials sit in your workspace, an autonomous agent might inadvertently commit them to public version control or send them over an unencrypted network. The Model Context Protocol, or MCP, is the bridge that fixes this. It securely connects the agent to external tools. The agent requests an action, like checking a database, and receives the result without ever seeing the raw authentication tokens. Implementing this protocol upgrades your setup from a potential security liability to an enterprise-grade system that can safely operate within protected environments. Autonomy also means the agent must manage its own version control. You shouldn't be the one manually staging and committing the files your AI teammate edited. You should instruct the agent to follow a specific sequence, create a new feature branch, implement the change, run the tests, and then commit the passing results. This ensures that when the work is done, you have a clean, verifiable history of every change the agent made, integrated into your existing workflow. Finally, you must manage context exhaustion. The longer a single session runs, the more likely the AI is to repeat itself or forget a decision made 20 messages ago. To prevent this logic decay, enforce hard session boundaries. Once a feature is committed, wipe the active memory and start a fresh session to keep the model's reasoning sharp. Combining automated Git checkouts with disciplined session resets ensures the system stays productive while maintaining strict coherence over long projects. We've combined baseline memory, specialized skills, and secure MCP tooling into a single, unified environment. The chaotic, forgetful terminal has been replaced by a configured environment that handles implementation details according to your specific rules. The practical capability of an AI model is determined by the quality of the scaffolding you build around it. Take 5 minutes to create your project's core rule file today.
You will see the difference in reasoning and reliability the moment you start your very next session.